Okay, so the last transformation that we're going to do is the phase shift. Okay, so that is your horizontal shifts. So from our previous work on transformations, you should know the graph of y equals sine theta plus 90 can be drawn by taking the graph of y equals sine theta and shifting every point 90 degrees to the left. Okay, left because it's a positive one, remember? So this one would go 60 degrees to the right. This one has a combined transformation, okay? So you have a k value of 2, but you also have a phase shift. Now the phase shift, if you remember, is not going to be 90 degrees because you have to factor out the k value and from the c value or p value, whatever one you want to call it. All right, so we're going to do these. So the very first thing that we're going to do is we're going to graph y equals sine theta. And I'm going to continue to do it. Okay, so there's my sine theta. Now, I am going to indicate my start points here. So I'm going to circle where I'm starting. Remember, you're always starting, well, closest to the y-axis. And you'll see what I mean by that. All right, next graph. This says move 90 degrees to the left. So every one of these points is moving to the left. All right, so I'm just going to move the very first one. Moves to the left. This moves. Okay, 90 degrees is 3 squares. Okay, so this moves 3 squares to the left. This goes 3 squares to the left. So now we have one complete rotation. Okay, so there's our one wave. And that means we still have to continue. So where's the graph going to go from here? Well, it's going to go up. Well, that means it's going to be here, right? Because you're going up 2 over 3. That's going to continue up 2 over 3. So you have to continue the graph until the edge. Okay, don't just do one wave and leave it. I want to go right across. So for this one, you know you're going to have a point here, a point here, and a point here because you're just continuing this wave. Okay, so it's going to look kind of weird, but actually when I look at this, I see cosine, because remember, cosine wave starts at the top, goes all the way down, comes back up, ends at the top. So this is your cosine wave, and if you look back in your notes from yesterday, you'll see that was the transformation from getting the sine wave to look like the cosine wave. Alright, so let's look at this one. Oh, you know what I forgot to do? I forgot my starting point. That was my starting point, because remember I moved this point 3 squares to the left. Alright, so let's look at this. Going back to the start, this says go 60 degrees to the right. Okay, well to the right, 30, 60. There's my start. Oops, I want green. There's my start point. So right now, I'm going to circle it. So that means every point is going 60 degrees to the right. Alright, so you can go ahead and you can do that. Whether you are technically moving every point or whether you remember sort of the pattern of the wave. Okay, that's going to be up to you. So again, we're going to end off, well, not at a nice point here at negative 360, but again, you know you're going down 2 over 3, so down 2, 1, 2, 3 would lead you here. At least it gives you something to strive for, okay? So I'm going to draw it in. Okay, so you can see my green graph, a little wobbly over here, but you can see what's happening, okay? All it's doing is being shifted left or right along the same parameters, okay? High is 1, low is negative 1. Alright, so let's take a look at this one. This was actually factored for us up above, and it read y equals sine, and you have square bracket. You separate your k value, so you're factoring your k value out from what was in here, so it's going to be theta plus 45. Now close your brackets. Alright, so this says you are doing a compression horizontally and you have a shift 45 degrees to the left. Alright, so when you do your transformations here, the 45 degrees to the left is going to be more helpful in terms of a start point, especially when you're dealing with the sine wave, but you should go through your transformations from left to right. If this is the normal start point, because it's my blue graph again, the 2 isn't going to do anything, right? You can't compress something that's sitting on the y-axis. So the only thing that you're going to deal with here is you're going to go 45 degrees to the left. So this is going to be my new start point, and I'm going to circle it right away. Now I'm going to consider the fact that I have to compress my graph. So how did we do that last time? We had a little formula that we did to find out the length of the period, and it was 360 divided by the k value. Well, my k value is 2, so that means my period length is 180 degrees. Okay, so if it's going to start here, it's going to end in 180 degrees. All right, so 30, 60, 90, 180. All right. Okay, so if it's starting and ending here, halfway in between, it's got to hit the theta axis again, or the axis of the curve. Halfway between the start and the middle, it hits its high point, which is going to be here. Halfway between the middle and the low point, or sorry, the middle and the end point, it will hit its low point, which will be here. So again, you've got one complete wave. And you're going to use this wave to construct the rest of the waves as you go. Okay? So again, just look at the mechanics here. You're going over 1.5, up 2. So up 2 over 1.5. So you're going to find that every high and low point will be on a nice point, but all of your points on the axis of the curve are going to be in between points. Okay? So over 1.5 and down. Over 1.5 and up. Okay? Alright, draw it in. Okay, so I have drawn in my purple graph, and you can see I have 2 waves, wrong way, 2 waves. Okay? And you might also notice that it starts at its high point and ends at a high point. You can see the cosine wave quite easily here. So I'm hoping you're looking at that too. Alright, so we did this sort of on the fly, but we can fill it in now. The phase shift for y equals sine theta is 0. Okay? There is no phase shift. Here, you're going 90 degrees left. I'm just going to do this quickly. So here you're going to go 60 degrees to the right, because it's negative. And with this one, we had to factor, and we went 45 degrees left.